So here's what a P series will look like, because like identifying them when they're all mixed up together is always the hardest part. So it'll be, summation. I wrote 1 to infinity, but wherever the first term isn't going to change whether it converges or diverges. The only one that's kind of important on is geometric. So you're going to have 1 over n to the something. So 1 over n to the first, 1 over n squared, 1 over n to the third, whatever have you. If P is greater than 1, then the series converges. And if P is smaller than 1, but it's not going to be less than 0. So we say in between 0 and 1 or equals 1. And we're going to talk about that one specifically in a minute here. Then the series diverges. So it's not real hard. You just look at P and see what it is. Bigger than 1 converges, smaller than or equal to 1 diverges. But again, none of these tests are all that hard by themselves. It's when they're all jumbled up together and you have to keep it straight that stuff starts getting difficult. Okay. Now, just as a side note, because do you remember months and months ago when we did the improper integrals and I brought this up and I said we're going to discuss P series later? Just as a side note, when you have the integral from 1 to infinity of 1 over n to the P, or actually here, let me use x. I'm sorry. Because whenever you have an integral, we have to put a dx at the end. Let me write x to the P and then dx at the end. You can work that out by hand. Do limit as b goes to infinity, integral 1 to b, and then actually like work it out by hand like I was doing with all the homework ones. But your shortcut for this is 1 over P minus 1. But what it's important to remember is, but this is not what the series converges to. That's just what the improper integral converges to. It's not what the series converges to. You're not usually asked what the series converges to. You're just asked, does it converge or does it diverge? It's kind of like a either or kind of thing. And then you have to explain why using a certain test one way or the other. But if you get asked about the improper integral, this is kind of like your shortcut. Okay. The other thing to notice is these are basically a reversal of the geometric ones. Remember how if R is smaller than 1, it's going to converge, bigger than 1, it's going to diverge. So just remember they're backwards to each other. Okay. And then I want to talk about a special one, which is if you just have 1 over n, what would P be for that? That's n to what power? Since nothing is written, it's what? 1. Okay. So would this converge or diverge if P is 1? Would diverge. This diverges because P equals 1, which is less than or equal to 1. This is called the harmonic series. So that's like a special one. It's called the harmonic series, and it does diverge. Now, if you see one like this, I'm basically just bringing this up because I think it's cool. I don't think it's very likely that you're going to see one like this, but just, I think it's cool. If you see one like that, like in that format, that is the general harmonic series. And what's cool about that is strings with lengths that form a harmonic series produce harmonic tones. So if you're into music or play a stringed instrument, I just think that that's cool. If you list out the values in the series, and then have an instrument with strings that are those lengths, they'll create harmonic tones. That's cool. Are you asking me a physics question? I don't think so. But here, you know what? Let's list out the first couple for this one, because this one's not too bad. If you plug in 1 for this one, what do you get? 1 All right, and then what would the next number be? If you plug in 2, 1/2, and then 1/3 and 4th. So like, I don't know how to build a guitar, okay, but like the way I understand it mathematically is if your strings were following this pattern, now I guess you couldn't do 1 inch, that would be super tiny, but like 1 foot or dimension, then they would make harmonic tones, which is just cool. Anyway, I just brought it up because I think it's cool. Let's just do a couple examples. You don't need to do a whole ton of these to get it because it's the P series are pretty straightforward. Honestly, the hardest part is figuring out what P equals if you have a root in there, because I know that kind of like throws everybody off. Sum from 1 to infinity, 2 over 4th root of n. Now, oh, were you gonna ask something? When we go to write out these answers, I'm not going to say because the series is a P series and blah, 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 because we're covering P series and they all are. But again, on your test, when they're all mixed up, you would have to say this is a P series. All right, so looking at the first one, P is what? 3. 3 is bigger than 1. So what's it gonna do? Converge. Converges because P equals 3, which is bigger than 1. And again, if they were all mixed up like on a test, you would say converges because this is a P series and P equals 3, which is bigger than 1. You just have to mention that. What's that? Yeah, like you just have to mention what it is. All right, this is n to what power? 3/2, good. 3/2 is greater than 1, so converges because P equals 3/2, which is greater than 1. I know you're probably thinking like, that's it. Yeah, that is it. But again, like for geometric, that's it as well. It's just hard when they're all mixed up. All right, this is n to what power? 1/4. 1/4 is less than 1. So we're going to say diverges, good, because P equals 1/4. I would still put less than or equal to 1, because again, if it equals 1, that would still be diverges. The rule is less than or equal to 1. And then this last one, P is 7, so converges because P equals 7, which is greater than 1. Now humor me for a second, because that's all the notes for today. So we have time for me to talk about this. For the ones that converge, if you did have the improper integral, it's worth talking about because it is such a nice shortcut. If you saw a question like this, it would be 1 over P minus 1. So this would equal 1 over 3 minus 1, which would be 1/2, and you could get the answer super, super quick. Like if they threw a multiple choice on there like that, is that what the series converges to? No, it would be greater than that. This one, that's what the integral converges. The improper integral converges to that, but it's not what the Oh, see, I keep writing n. Whenever you write it with an integral, it should be x, because then you have to put dx at the end. So this would be 5 over, and then what did we say p was? 3/2 minus 1. So 3/2 minus 1 be 1/2. 5 over a half. 10. Guys aren't writing it out. I just like, I'm bringing it up because if they do this on the AP exam, it's like you can get the answer very quickly. And if you can get an answer like fast like that, you want to do that because it's a timed test. Like if you can just get an answer, that's great. This one would be 3 over 7 minus 1. So 3/6, so 1/2. So again, all it tells you is that the series converges. Or if it's smaller than or equal to 1, that it diverges. But if you get asked about the improper integral, you can actually get that answer really fast, which is nice.